I'm going to go over every single problem from physics competition 4, of course. And understanding this problem will help you do well in the midterm, and we're going to have midterm in January. So in the break, you're not going to you're not going to be able, you're not going to only celebrate Sir Isaac Newton's birthday, but also you're going to make sure that you have full understanding of the concept we covered in 2022, especially exam 1, exam 2, exam 3, exam 4, exam 5, and exam 6, quiz 1, quiz 2, quiz 3, quiz 4, quiz 5, and quiz 6, and also the physics competition 1, physics competition 2, physics competition 3, physics competition 4. From now on, all exam will going to be in cumulative. And also, for some reason, if you don't take the exam, the makeup, of course you can take a makeup whenever you want, but I will not give you the same exam. I'll create a different exam for makeup. So I'm trying to be fair with everybody when it comes to grading. If you have, my main goal is, if you have a full understanding, then that's all I care about, full understanding. 99% understanding not going to put you at Harvard. 100% understanding requires to get accepted at Harvard, and unless everyone make sure that everyone, when I say everyone, I mean everyone aim to Harvard. Problem number 1, let's go over the problem number 1. So problem number 1 is like this. You have a vector, and vector is, of course, A is 32 Newton. I'm going to draw it again. Problem number 1 is, this is A is 32 Newton, and then B is 20 Newton. Of course, when you take the ruler, you measure it, and you see that A is 8 centimeter and B is 5 centimeter. And I ask you, 1 centimeter is equal to how many Newton? That's the problem I ask you. Now, there are many ways of solving this problem, but the easy way is, write 8 centimeter is equal to 32 Newton. It is equal to 32 Newton. That means you divide both sides by 8. And so 8 cancel, 8 goes to 32, 4. So 1 centimeter is equal to 4 Newton. So you report what you see, 1 centimeter is equal to 4 Newton. You can also do it this way, and you can write 5 centimeter is equal to 20 Newton. So divide both sides by 5. So 1 centimeter is equal to 4 Newton. You verify it. Now you're going to draw it to the scale, is because I'm going to hold you responsible to draw things to the scale. So let's draw the first vector. First vector is 8. I'm going to multiply it by 3. So 24. This next vector is 5. I'm going to multiply 3 by 15 Newton. So the first one is 24 Newton. So I'm going to exactly have 24 Newton, no more, no less. All right. Now, make sure you know how to draw this thing to the scale. I'm going to take the protractor. I'm going to make sure I have 120 degree. So this is my 120 degree. Okay. So I'm going to make a line from here to here, and that is my, I want to make sure that this is 15 centimeter because this is 24 centimeter. This 24 centimeter I'm going to call 32 Newton A. This 15 centimeter, I don't even know whether this is 15 centimeter, so I have to verify it. So I have to verify whether this is actually 24 centimeter, 15 centimeters. So this is uh, this is uh, uh, this is 15 centimeter. 15 centimeters right here. Okay, now I have to make sure that this angle is of course 60 degree. So I put a hole over here on the arrow. There is a small hole on the projector. All right, and then I put the dot at 60 degree. So this is the 60 degree AC. This is the 60 degree. All right. So now I'm going to connect this to arrow or dot as big as possible. And I'm going to make 60 degree over here as well. So put the hole over here. And 60 degree is right here. So I'm going to draw a line over here. Also as big as possible. All right, so now since I have, this is like a pencil I can erase. So make sure I have the arrow. If you don't have the arrow, then you are wrong. Then I don't know what you have. They are not vector. No arrow, no vector. All right, this is drawn to the scale. Now, the next thing you're going to do, you're going to draw the resultant. You have this is A, you have this is B. You know A is 32, B is of course how much? 20, and you're going to see the resultant. So this is, make sure you have the arrow. If you don't have arrow, you don't have resultant. And of course you're going to say R and hat. So this is your resultant. Now you're going to take the ruler to find the size of the resultant. Since you draw it to the scale, you should get the correct size. So this is 21. So I'm going to go ahead and write 21 centimeter. Divide by 3, so it's 7 centimeter. Why I divide by 3? Because I multiply by, of course, 3. That's why I divide by 3, 7 centimeter. Now I'm going to write R is equal to 7 centimeter. And of course, centimeter is bottom, Newton at the top. 1 centimeter is, of course, 4 Newton. How do I know? From here, centimeter cancel. So resultant is 7 times 4, 28. And there is a Newton as a unit. Put the arrow on the top. So this is how you're going to do problem number 1. Now let's go over problem number 2 by parallelogram. So now again you want to write this one. This is a law of parallelogram. Law of parallelogram. So you're going to write R squared is equal to A squared plus B squared plus 2AB cosine R. Or cosine theta, doesn't matter. So R squared is equal to 32 squared plus, always remember this angle which is given 120. This is also 120. This is 60. This is 60. This is always parallelogram. This is always parallelogram. This is always law of cosine. And this is always law of cosine. So what do we learn? Tail and tail is parallelogram, head and head is parallelogram, head and tail is law of cosine, and head and tail is law of cosine. Okay, 20 squared plus 2 times 20 plus times 32 cosine, you have to use 120. So R squared is equal to 32 squared plus 20 squared plus 2 times 20 times 32 minus half. So R is equal to 28 Newton. So this is how you're going to find the resultant using, of course, the law of parallelogram. Now we're going to use the law of cosine. Law of cosine would be also very easy. So now let's do it by using other color. R squared is equal to a squared plus b squared minus 2ab cosine 30. So since you're using law of cosine, you have to use the head and tail method, and you used to use the head and tail. So head and tail is what? 60. Head and tail is what? 60. All right. So r squared is equal to 32 squared plus 20 squared minus 2, 32, 20, and this is half. So R is 28 Newton. So now we're going to do the geometry. To do the geometry, you see that it is super easy. What we're going to do over here is this. You're going to use 30, 60, 90, properties of 30, 60, 90. So this is your, of course, by, because this is your b. And b is, of course, you see b is 20. And this is your bx. If this is 120, this has to be 60, and this is 60, this has to be 30. All right, so now what I'm going to do, I'm going to copy and paste. All right, so this one is 60 degree, so I'll write 60. This one is 30 degree, I'll write 30. This one is 90 degree, I'll write 90. Opposite to 90 is 2x. Opposite to 60 is x root 3. Opposite to 30 is, of course, I don't know, x. So 2x is equal to how much? 2x is equal to 20. 20. So x is equal to 10. So 10 is square root of 3 is 17.3. And 10. All right. So now it's easy to find it by geometry. So you have a black line, which is what? 32. You have a red line, which is how? By is, of course, 10. 10. So 32 minus 10 is, of course, 22. So we have 22. And then you have over here is bx, which is 17.3. 17.3. And now you have to find the r, and which is very easy. So r square is 20. I don't know why. Let's see. It's something. 70.3 square, and that is 28 Newton. Next, we're going to do it by law of sine. Let's use law of sine. To do the law of sine, what we're going to use, I'm going to use this. You see the red over here? I want to just copy and paste this side. This red doesn't work. So you see this red. I'm going to draw this red. Let's first draw this black vector. Draw this black vector, and how much is this? Of course, a, which is 32. So let's call it 32. Draw this also black vector. B is 20. So let's write 20. Draw this red vector. We don't know how much it is because we are using law of sine. We're gonna find it. So we're just gonna call R. This is our resultant. What else we know? We know this angle if you use the protractor, and I'm gonna use the protractor. I'm gonna place it like this. Place it like this. and it's going to tell us this is 40. This is 40. So if this is 40, this must be 80. All right. That means this is 80 and this is 40. Interior opposite angle are congruent. So 40, 40, 80, 80, 60, 60. Notice this is not a right angle triangle, so you cannot use SOHCAHTOA. This is not a right angle triangle, so you cannot use a square plus b square equal to c square. No. No Pythagorean theorem, no SOHCAHTOA. What you can use? Well, you can use a law of sine. You can call it A. If you call it A, you must call it A. If you call it B, you must call it B. So of course, now we have everything we're looking for. So of course you are solving for R, so put the R over here. So you can call sine R. So this become all sine R is equal to, let's talking about A. So A is sine A. So R is what we're looking for. Sine R is of course sine 60 is equal to A. What is A? A is 32 over sine A. What is sine A? Sine 80. If you do cross multiplication, you get R is equal to 32 sine 60 over sine 80. And which give you, of course, 28 Newton plus minus 1 Newton. Because I asked you that, I would accept only 5% error. Only 5% error, so you cannot put 2. 5% error means 1. Because if this is a true answer, which it is, then it could be 27 Newton or 29 Newton. Both is true because both falls within 5%. How do you know? This is your, say this is your measurement minus the true value. This is your measurement minus the true value. Divide by true value. Divide by true value. Times 100%. Times 100%. All right, and this is give you 3% error, and of course 3% error. This is also give you 3% error. 3% error is less than 5% error. So I'm good with this. However, if you put 2, it's not gonna give you 3% because all of a sudden this is gonna become 26, and this is gonna become 30. Then the answer going to changes. Of course, you are talking about absolute value. This becomes 7% error and 7% error. And I do not accept 7% error. 7% error is not less than 5% error. So this I don't accept. I accept only 5% error because you have more skill now. In the beginning, I accepted, of course, 10% error. Now I accept only 5% error. Now let's do it by trigonometry. So many people made mistake with the trigonometry, not sure why. All you needed to do is use the trigonometric tree diagram that I gave you. So, all right. So this is what you have, and I'm gonna erase everything to make it look better. So this is what you have. Okay, so this is what you have. This one is of course B, and B is 20. This one is A, and now A is 32. Okay, so you have a vector B or vector A and B. A has AX and AY. B has BX and BY. talk about ax, but before you do anything, you have to make sure that there is a x and y. So let's draw x and y for you by purple. This is your x, this is your y. Always you're going to be imagining x and y. If you don't, no good. So what are you going to be writing? You're going to be writing, of course, which one you want to start with. Let's start with A. I ask you, hey, put your protractor over here and measure the angle counterclockwise. If you do with respect to x, then it's 90. So since A is 32, so 32 cosine 90. 32 sine 90. And B, you can measure it like that. Of course, you can measure it like that. If you do, it's tricky to measure it by protractor. But one thing you can do, you can measure this one. This is going to give you negative 30, which is negative 30 because this is clockwise. So you can write, this is B is 20. You write 20 cosine negative 30, or you can write 20 cosine 330. They are the same thing. Okay, they are the same statement. Now By, of course, you're going to write 20 sine negative 30 or 20 sine 330. Of course, this is 0 and this is going to give you 32 and this one going to give you 17.3 and this one going to give you negative 10. Negative 10. Calculator will give you. Alright, so this is your x. So you write ax, resultant is, first add them up, ax plus bx, which is going to be your rx. Ry would be bx plus by. What is your ax? 0. What is your bx? 17.3. So rx is 17.3. What is your bx? Bx is 7. Bx is what is it? By. Ay. Ay. What is your ay? Ay is 32. What is your by? By is negative 10. Which is 22. All right, excellent. So now you know everything. You know your r square or r is equal to rx square plus ry square. And this is 17.3 square. And this is 22 square. So your r, make sure you show the r. If you don't, then you lose point. Your r is again 28 Newton for the above reason. All right, now I'm going to use a distance formula right now. To do the distance formula, all I need to do is very simple. I'm going to come over here. This is my b. I need the y component of the b. So this is the y component of the b. So I write b, y. And this is the x component of the b. So I write bx. So now I have y component of a, ay, y component of the b plus by. Okay, is equal to ry. I have x component of the a, 0, we'll write it down, plus x component of the b, which is rx. Ay is 20. AY is 32. BY is 10. Right? How it is 10, you're probably thinking. It's 10 because we already explained it. So BY is negative 10 because the arrow is down. Negative 10. So this is 22. This is 0. This is 17.3. So this is 17.3. So I have 22 and I have 17.3. I have the resultant. So this 0, 0 and this one is 17.3, 22. So the distance formula, as you know, which is of course R. R is square root of x2 minus x1 square plus y2 minus y1 square. So R is, this is x1, this is y1, this is x2, this is y2. Y2 is, x2 is 17.3 minus 0 square plus y2 22 minus 0 square. So R is equal to 17.3 square plus 22 square. So R is of course 28 Newton. So we are done with this two vector problem. Now we're going to do one more thing, and that is called why we have to use the uncertainty. And what does that mean when we are talking about 1% or 2%? So problem 1, since we had to do the hand measurement, so this is A is 32 and this is B is 20, and we had to do hand measurement. So this is A is 32 and this is B is 20. We had to do the hand measurement. So however, I ask you to use the ruler and the protractor. So there would be human error but less. That's why I said that 5% would be acceptable. And the true answer is 28 Newton because it's 7 centimeter. 1 centimeter is 4 Newton. Okay. However, we are not sure because 28 Newton is in the middle of is between, if we use the 5%, then it is plus minus 1, 5%. If you use 10%, this is plus minus 2. Plus minus 1 means you have 27 and 29. So the true value is between 27 and 29. And this one is true value is 26 and 30. Now, if you ask someone what time it is, and someone said it is what time it is 5 o'clock, but plus minus 10 or plus minus 5. So, or plus minus 3. If you ask someone what time it is, and then someone says 5 o'clock plus minus 3, then it could be 8 or it could be 2. So it's between 2 to 8. That's not very reliable. On the other hand, if someone say it's 5 o'clock plus minus 2 minutes, then that's pretty much what you like, right? Okay, so this is much better. Also, this is very hard to accomplish because you have to use protractor and you have to use the ruler. How do you know this is 1%? Well, very easy. The measurement minus the real value, absolute value over the real value. This is absolute value times 100. So and then we're going to do it for 27 and then 29. So measurement minus real, the real times 100%, and then we're going to do this one, measurement minus real times 100%, and then measurement minus real times 100%. All right, so let's do it for 27 minus the real is 28 and 28, and that is 3%, and 3% is less than 5%. Good. And this is 29 minus 28, and this is also 3%. So 3% is less than 5%. So that's good. Now come over here. This is not good. This is not 5%. Why? This is 26 minus 28, and that gonna give you 7%, and 7% is greater than 5%. Now good. This is 30 minus 28 over 28, and this is gonna give you 7%, and 7% again. No good. And the one word I ask, that is, of course, the human error. Measurement comes with the human error. You can call it one word or you can call it two words. All right, the next thing and final thing, I'm going to go over the messy problem. I'm going over problem number 9, and then finally we're going to go over problem 10. Pay attention to problem 9 and 10. It's going to be in the midterm. And midterm, I'm not going to curve it. If you get 0, you get 0. If you get 100, you get 100. There would be no extra credit, no correction. So this is the soccer ball trajectory. All right, this is where the soccer ball is kicked by Messi, and this is where the France goalpost is. France goalpost, 8 meter. However, the ball is here, over here, and the height of the ball is, I told you, 10.45 meters. I want you to find the velocity vector over here. What would be the velocity? What do I mean when I say velocity? I mean you have to find this one, this is Vx. You have to find this one, this is Vy, and that will give you the velocity, xy, or you can call resultant. And that's resultant. We're talking about resultant many times. So that's again resultant. How can I find the Vx? Well, let's see. This distance is of course 50 meter. The Messi shoot the ball 30 meter per second with 30-degree angle. So I just want to quickly get the x and y. Velocity 30 meter per second, cosine 30, which is 26. 30 meter per second, sine 30, which is of course 15. I already know one component, and that is 26. I need to know the other component. This component I know because, hey, this one doesn't change. The other one, of course, is not 15. It would be wrong if you were 15, because the other one changes. All right? Don't get easily confused. So other one I'm going to find by Vf is equal to Vi plus At, of course. Vf at location, that location right here. So how do I know the location of this? I know the time, right? So I have to find the time right here. Time right here is how much? Well, the time here right here is time is equal to dx over Vx. So dx is of course 50 and Vx is of course 26, so this is 1.9. I want to find the velocity at the y direction at 1.9. So how much is this? Velocity initial at the y direction is 15 minus 10 times t is 1.9. So velocity is 15 minus 19. So velocity is minus 4. All right. So now I have everything I need. So this one is minus 4. So now this one is, of course, now it becomes super obvious. 26 squared plus minus 4 squared. So 26 squared, I'm going to use the calculator. 26 squared plus squared is, so take the square root, 692, and that is 26.3. So R is 26.3. So the velocity of the ball right here is 26.3 meter per second. And that's the answer I was looking for, and nobody gave me that answer. So the problem number 10 is pretty much problem number 9. Okay? So problem 10, I ask you that, hey, can you prove that from here to here is actually 10.45? I gave you the answer. All you need to do is prove that. So again, height means Vy. You have to know that. So this one minus this one has to be 10.45. To know this one, you have to find this one. Because this is this minus this. This is 15. So velocity initial is 15. You need to know the entire time, right? How do we know the entire time? From here to here? No. From here to here? No. From here to here is 1.9. But from here to here, everything. And that is how much? Let's see. dy is equal to VIYT plus half AYT squared. 0 is equal to 15t minus 5t squared. 0 is equal to 5t, 3 minus t. So 3 minus t is equal to 0, t is equal to 3. If the entire tree from ground to ground, t is equal to 3, that t is equal to 1.5. And this t, right, in the half right here, t is 1.5. Right here, t is 3. So right here, t is 1.9. 1.9. When 1.9, we already know the velocity at the y direction is negative 4. So negative 4. So let's find this one. Is half BH. So half B is 1.5 and H is of course 15. And this one, of course, again half BH. Half B is 1.9 minus 1.5, so that will be 0.4, and this is minus 4. All right. So now you say area 1, area 2. So area is area 1 plus area 2. Area 1 is how much? 7.5 times 1.5. And area 2 is area 2 is plus minus 0.8. All right. So area is 10.45 meter, of course. And what is the area? Area is height. Why? Because we are dealing with AYT. Everybody, happy holidays and happy New Year. Make sure you don't forget to celebrate Sir Isaac Newton's birthday on 25th December.